In this question, it is given that if a ball of steel of density 7.8 at a terminal speed of 10 centimeter per second when falling in a tank of water, coefficient of viscosity of water is given as nothing but 8.5 into 10 raised to 4. Then its terminal velocity in glycerin of density 1.2 gram per centimeter cube and viscosity 13.2 pascal second would be nearly. So over here we can write the equation for this terminal velocity, that is equal to nothing but 2 divided by 9 into r square g density of object minus density of liquid divided by the value of coefficient of viscosity. So again, right, these the terminal velocity is directly proportional to density of object minus density of liquid divided by the value of coefficient of viscosity. So you can write what about the value of terminal velocity when it is in water divided by the value of terminal velocity when it is in glycerin, take it as Vg, is equal to density of object minus density of water divided by coefficient of viscosity of water divided by this term. So we can take it as density of object minus density of glycerin divided by this term, that is coefficient of viscosity of glycerin. So we can write it in this form. Now density of water is like terminal velocity in water is given as something but 10, and Rm is to find out the value of terminal velocity in glycerin. Density of object is 7.8 minus density of water, we can take it as 1, divided by viscosity of water, we can take it as 8.5 into 10 raised to minus 4 into viscosity of glycerin, which is given as something but 13.2, divided by this is we can take it as 7.8 minus 1.2. So if you can write this is equal to 6.8 divided by 8.5 into 10 raised to minus 4 into 13.2 divided by 6.6. So we can just find out the value for it. So we'll get as 10 divided by Vg is equal to 1.6 into 10 raised to 4. So we can write the value of this terminal velocity, that is equal to 10 divided by 1.6 into 10 raised to 4, which is equal to 6.25 into 10 raised to minus 4.